In this video, I'm going to show you how to find the inverse of an exponential or logarithmic function. So I have some steps written out to the side for you to follow. And then the other thing that we need to remember about exponential and log equations is that if we're in exponential form, we have the base raised to the exponent and it's equal to the answer. And if we switch it to log form, we have log, the subscript is the base, then we put the answer, and then it's equal to the exponent. And so this is often we call like bay, and then we say log is bay, and then we switch it by doing the swoosh method. And so that would be base raised to the exponent is equal to the answer. So those are kind of the two tricks that we have here. All right, so if I am going to find the inverse, the first step to finding any inverse equation is to switch x and y. And when you're looking at number one, it's important to remember that f of x is y. They're the same thing. They're totally interchangeable. So then I'm going to switch x and y's location. So this becomes x is equal to 4.2 to the y plus 5. I just swapped them out. Now I want to get y by itself, so I'm going to take away 5. I need to get the... I'm going to put this in parentheses so that I can tell that it goes together. I need to get to the base to the exponent raised by itself. And now that I have the base raised to the exponent by itself, I am going to switch forms because the only way to get an exponent out of the exponent is to change form. So let me shrink this. And I have that log base 4.2 of x minus 5 is equal to y. So just like in our bay over here, our base becomes our base. So that was my 4.2 is my base. My exponent was y, and so it's always equal to the exponent in log form. And then I had my answer on the inside. So those are those parts. Now it's equal to y. Y is by itself. And so I'm going to rewrite it with our fancy function notation. So my final answer would be f inverse of x. It just means, hey, this is the inverse function. That's all it means. Log base 4.2 of x minus 5. And that's my final answer. All right, the second one, I have find the inverse of f of x equals 2 to the x. So I'm going to know that that's y, and then I'm going to rewrite it. X is equal to 2 to the y. And then I'm just going to switch forms. I already have the base to the exponent by itself. When I change forms, I have log base 2 of the answer is equal to the exponent. So base answer equals exponent. Logs always equal the exponent. I already have y by itself. That is all I have to do. So my fancy notation is just going to be to replace y with f inverse of x. Log base 2 of x. That's it. All right, number 3. I have y equals. So I'm going to change this to x equals 3 to the y minus 5. I switched x and y. Now I need to get y by itself. So I'm going to add this 5 to both sides. And then I am going to change forms. So this is log base 3 of x plus 5 is equal to y. Notice when there was more than just an x on the left side, I went ahead and put it in parentheses just to show that it goes together. And then my final step is just write it with inverse notation. So it's like we change f of x to be y, and then we change y to be the inverse when we're done. All right, now number 4 is a log example. And we want to find the inverse of that. And so I know that this is really y. So I'm going to start by switching x is equal to log base 3 of y. When we did 1 through 3, we switched from exponential to logarithmic form. Now we're in logarithmic form, so we're going to need to switch to exponential because exponential and logarithmic functions are inverses of each other. And so I am following the pattern base answer exponent. Mine's kind of written in reverse. So I'm doing that. The other way we switch out of log form is to think about the swoosh method. And so I have the base to the exponent is equal to y. And that's already got y by itself. So I'm going to rewrite it as the inverse function is 3 to the x. All right, the next one. We have a y again right here. I don't know what happened right there. And I'm going to trade out x and y. And then I'm going to do the swoosh method. So base to the exponent is equal to the answer. 1.2 to the x is equal to y minus 6. I can kind of drop the parentheses right here. I need to get y by itself, and so I'm going to add the 6. And then I'm going to write my fancy notation. The inverse function is 1.2 to the x plus 6. All right, one more example. I have y equals log base 2 of x plus 5. When there's no parentheses, it's like this is what's on the inside of your log and the plus 5 is on the outside. So I'm going to switch x and y. So unless they give you parentheses, you can assume just the thing next to the log base is part of your log and everything else is on the outside. And then I'm going to take away the 5 because I have to get the log alone. And then lastly, I'm going to do the swoosh method. So the base to the exponent is equal to y. So 2 to the x minus 5 is equal to y. And then I'm going to write it using inverse notation, that function notation. And this is how you find the inverse of an exponential or a logarithmic equation.